I want to go ahead and make a function that represents the age difference between me and Jinsu. Now, if I were to go ahead, use variable, let's say, Jinsu's age be my input. So I'm going to go ahead, assign variable J to be Jinsu's age, and L be Lauren's age. Right at this moment, I could go ahead and say L equals 2 times J because I believe he's 16 years old and I'm 32, so that'll be double. But technically, that doesn't mean that once Jinsu turns 17, I'm going to be 34, right? I will be turning 33, correct? I don't need to add extra years that I don't deserve. So I think the more accurate way of relating Jinsu's age and my age would be L equals 16 plus J, correct? And that's because I would always be 16 years older than Jinsu. Oh my God, that makes me feel so old. Anyway, so now we've established this relation, this function, and if I were to go ahead, graph this, I can go ahead and make a simple table like so, where I put J and L, and J, when J is 0, Lauren is 16. When Jinsu's, let's say, 10, I would be, I was 26. And when Jinsu would be 20, I would be 36, right? And you would go on and on. So let's go ahead, plot these points. And since this is, right now we are given specific coordinate points, but everything else in between would apply. So like, what I mean by that is like, when Jinsu was 2, I was 18. So all those numbers in between these specific points would be true to the function, right? So I can go ahead and graph it as so. So here, I get a linear function. And if you think about it, I have a specific point that intersects with my y-axis. And it's this point right here, 0, 16. So when x is 0, y is 16, right? And we call that, this particular value, y-intercept. And it is the value of y when x equals 0. Now, what I find really interesting is that this exact value, 16, appears in our function equation right over here, right? And just like we call L and J variables, because they're uncertain values, right? They're changing values. 16, something like 16 is unchanging, meaning it stays the same all the time, regardless of input values, correct? And we call values like this constant. So, since we have y-intercept, that means we must have x-intercept too, right? And if you take a look at our graph, see my graph continues all the way through the second quadrant and past the y-intercept, and somewhere over here, you can see that I have one intersection with x-axis. So since y-intercept is the value of y when x equals 0, x-intercept means the value of x when y equals 0. L to be 0, right? Because it intersects with x-axis, so we know that y value must be 0. So let's go ahead and find our x-intercept. X-intercept, the value of x when y equals 0. So when L equals 0, 16 plus j, in order for us to get 0, j must be negative 16, right? So my x-intercept is negative 16, comma 0. That must be the value. And what we realize is that, sure, we can see y-intercept very clearly in our function equation, but what about x-intercept? We know that it would have to be the value of our input in order to make our output to be 0. That's what x-intercept is.